Today we're going to talk about piecewise linear functions, which are a special way of gluing together several linear functions to get some more complicated relationship. These are often used essentially in human-generated situations. We're going to look at a couple today that involve how much people pay for things. We're also going to be looking at taxes, income taxes, which are based on piecewise linear functions in class. So our topic for today is understanding my electric bill. So here's the way an electricity bill might work. Every month, the electric company charges me just $10 as a delivery charge. That's what I need to pay to get electricity at all. Then they charge me 8 cents per kilowatt hour of electricity for the first 300 kilowatt hours that I use, and 12 cents per kilowatt hour after the first 300. So if I use a lot of electricity, my electricity gets more expensive. But before we try to understand this, we're going to take a little bit of a digression, because what's a kilowatt hour? So here's the idea. Electrical appliances draw some number of watts. A typical incandescent light bulb draws 60 watts. So a kilowatt hour is enough electricity to power 1,000 watts, that's a kilowatt, for 1 hour. Or it could be 100 watts for 10 hours. If you take the number of watts, the number of kilowatts drawn, times the number of hours that you're using those appliances, you get the number of kilowatt hours used. You don't actually need to understand this to do the rest of the problem, but I think it's worth talking through. So let's just look at an example for this bulb. This bulb draws 60 watts. That's 0.06 kilowatts. A kilowatt is 1,000 watts. So if you run it for 100 hours, you'll use 0.06 kilowatts times 100 hours, and it gives you 6 kilowatt hours. It'll be the same thing if you ran 50 of these bulbs for 2 hours, because then you'd be taking the 6 watts each, the 0.06 kilowatts, times the 50 bulbs, times the 2 hours. You try one. A toaster oven draws 1,200 watts, or 1.2 kilowatts. Turns out heat takes a lot of electricity. So how many kilowatt hours do you use if you run a toaster oven for half an hour? Give me an answer on the form. So the answer would be 0.6 kilowatt hours, because it's 1.2 kilowatts for half an hour. So now we're going to go back to understanding my electric bill. This is the same description you saw before. Let's ignore that bottom line for the time being. And let's just say, what happens if I use less than 300 kilowatt hours? In that case, I will be charged the $10 and the 8 cents per kilowatt hour. So I'd like you to write an equation relating W, the number of kilowatt hours, to C, the amount of my electric bill. Type your answer for the equation on the form. And also, there's no good way to put this on the form, but I'd like you to sketch the graph of the equation in your notes or on a piece of paper. So your equation should look like this. This is a standard linear equation. It starts at $10 and it goes up by 8 cents, $0.08 for every watt that you use. And here's the linear equation graphed. It starts at $10 and really it's just going up. That's what we can see, and it's a straight line. Now, how much do you charge if you use exactly 300 kilowatt hours? So just do that calculation and tell me the answer on the form. To do that, you would plug 300 into our equation. You're charged $10, and then you're charged 8 cents each for 300 kilowatts. That works out to $34. So over here, at 300 kilowatt hours, you've hit $34. So now let's try to move on to the next part. If my electricity, if I use a lot of electricity, it becomes expensive, and they charge me 12 cents per kilowatt hour after the first 300. So they're not going to go back and charge me more for those first 300. They're going to just start charging me more for extra ones. So what do you think my bill will be if I use 301 kilowatt hours? Give me an answer on the form. I pay that $34 that we already calculated for the first 300 kilowatts, and then I have to pay for one more expensive kilowatt hour. That's only 12 cents because there's only one of them. So I'd pay $34 plus 12 cents, or $34.12. So now what if I use 400 kilowatt hours? I want you to do that calculation. and give me your answer on the form. Well, again, I would pay for my 300 cheap kilowatt hours. Then I would have an extra 100. How many more than those 300? An extra 100 expensive ones. So it'll be $34 plus 12 cents, $0.12, times the fact that I'll need to pay 100 for 100 of those, and that works out to $46. Okay? I want you to sketch a graph in your notes of what you think your electricity bill would look like if you use W kilowatt hours of electricity. This is like the graph you just did before, but now I want W to go from 0 to 600 watts. So think a little bit about what all of these different numbers are going to mean. Your graph should look something like this. It starts at 10, it goes up, and then at 300, it changes, and it starts going up more steeply after those 300 kilowatts. It's just a bend. It isn't a sudden like jump. It doesn't break, but it bends. And that's why we call these piecewise linear functions. They look like two lines glued together at some point where everything pivots. So what we want to do is write an equation. So what would the cost of your bill be if you use W kilowatt hours, where W is bigger than 300? I want you to get whatever thoughts you have on the form. It's okay if they're partial. So go back and remember, if I used 400 kilowatt hours, you did this calculation. You were charged $34 plus 12 cents times 100 expensive kilowatt hours, or $46. And often if you're asked to write an equation, it can be helpful to do a calculation with some specific value. So let's look at what this equation turns into. It's $34 plus 12 cents times, where did that 100 come from? That was how many past 300, or 400 minus 300. So looking at this, if we replace that 400 with W, we would get the shape of an equation. If I use W kilowatt hours, I'll be charged $34 plus 12 cents, $0.12, times W minus 300, as long as W is bigger than 300. So let's make sure we understand all the pieces in that equation. It's like, where did that 34 come from? I don't see that 34 in the description of the problem anyhow. So remember where that 34 came from. It came from figuring out how much I used at the changeover point at 300 kilowatt hours, and then using that as the starting point for our expensive kilowatt hours. So I plug 300 into this equation, and I get $34. And then I start at $34, and I add 12 cents for every kilowatt hour that I use after the first 300. And that's what this part in parentheses says. It says the number of kilowatt hours after the first 300. So all of this packages up together to give me the equation for how much my bill would be if I use more than 300 kilowatt hours. This doesn't look like a classic linear growth equation. You could simplify it if you wanted to, but really, I like it just like this, because like this, it really describes exactly what's going on. So I can take all of this and package it up into what we call a two-part equation. This is one formula. It just breaks over two pieces. I have one equation if I use less than 300 kilowatt hours, and then I plug that changeover point in to get the starting point for my next equation, and I multiply by W minus 300. So that's how you would write an equation for a piecewise linear function. I'd like you to try one yourself. We're looking at actors who make commercials, and it turns out they're paid based on the number of times the commercial airs. This is an actor who is the lead in a commercial that airs on network TV, on prime time. They're paid $428 to make the commercial, $97.35 per time the commercial airs for the first 13 times it's on the air, and $46.65 per airing after the 13th. So I want you to figure out how much an actor will be paid for a commercial that airs 13 times. That's a changeover point. What about 20 times to practice it? And then write the two-part equation for the amount the actor will be paid based on the number of times the commercial airs. Gives me your answer to those on the form. And I have only one more slide in which I will give you my solutions. Here are the numbers that I came up with. You can take a look at those and see if those match yours. We'll be talking about this in class, so certainly bring in any questions that you have. As I said, these piecewise linear functions tend to be used for human situations, bills and how much you're paid and things like that. We'll be looking at a very important class of example of taxes in class.